Okay, guys, so we are going to discuss the second problem, meeting the origin. Okay, so like this is like like the simplest problem of this entire set, I think. Like we would be given a string s which is going to denote the path, and like path is going to be denoted by like there are a set of moves left, right, up, and down. And if you're going to move to the left, it is going to be denoted by capital L. Similarly, R, U, and D. Okay, and we are at origin 0, comma 0, and we have to follow the directions in the path in the order like from left to right. Okay, and whenever we are going to move to the left, and it is going to cost me a 1 unit. Similarly, R, U, and D. Okay, and there are set of operations that can be done any number of times, like any L can be interchanged with R and vice versa. Similarly, any U can be interchanged to D or vice versa. Also, we can delete any sequence of moves, like we can delete any L or R. Similarly, U and D, we can delete any of these four characters. Okay, and we need to print the minimum operations required, which is going to the new path and coming back to again to the origin. Okay, so let me explain it in a simpler manner. Okay, so let me just change this one. Yes, I think this should be fine. Yes, okay. So what I'm going to explain is like suppose you are at this origin, and whenever you move to the right, it will cost you a single 1 unit, and it is going to be represented by R. And you whenever you go to the left, it is going to be represented by L, and it will cost you 1 unit also. And similarly up and down. Okay, and you are initially at origin, and there is a string as like a string is given, and string characters are s0, s1, s2 up to s of n minus 1, denoting the paths, and all these characters are either L, R, U, and D, and you need to follow this string starting from the left to the right, which is going to denote the path. And after all the strings, like all the characters has been traversed, you are going to have some value L. Okay, so let me write down. You are going to have some L value, and similarly, you are going to have some R value, and similarly, you are going to have some U value, and similarly you are going to have some D value. Okay, which is going to denote the number of times these characters have occurred. Okay, so when let's say you have L amount of let me write down in a next page, let me think. Yes, that would be better. Okay, so you have, let's say, X amount of L, and you have the Y amount of R. Similarly, you have Z amount of this, and similarly you have W amount of this one. Okay, and you are starting at the origin 0, comma 0. Okay, so like X coordinate is going to be represented by this one, and Y coordinate is going to be represented by this one. Okay, as we all know that up and down manages the Y coordinate, and left and right manages the X coordinate. Okay, whenever you move to the left, X coordinate decreases by 1, and whenever you move to the right, X coordinate increases by 1. And since we want to stay back to the origin, like we are starting at the origin, and we want our paths to be such that we are going to end up to the origin again, so it means that X should be equal to Y, right? And also Z should be equal to W. Then only and only we can traverse the path and come back to the origin again. Okay, now the problem lies how we are going to reach this condition with the given operations, and we need to find out the minimum number of operations required to make X exactly equal to Y and Z exactly equal to W, where X is the count of L occurring in this string, Y is the count of R occurring in this string, similarly Z and W. Okay, so let me explain this in a simpler manner. We need to manage X and Y. Okay, so like suppose X is odd and Y is even. Okay, so let me take an example and explain you. So X is odd is 7 and Y is even is 4. Okay, so there are 7 times L. Let us suppose this, okay, 7 times L and 4 times R. Okay, we need to manage this one. That is the operation. We can convert any L to R, and also we can delete any character. Okay, so what we are going to do is, like, since the count of L is going to be greater than the count of R, we are going to remove this L and make this R. And again, you can see still the count of L is greater. You can remove this L and make this as R. Can this be a feasible operation? No, you cannot. Like this cannot be a feasible operation because it will cost you 5 times L and it will cost you 6 times of R. Okay, and again the R count is greater than this L count, and this goes on. So at this step, converting any L to R is not a feasible operation. Okay, so what you're going to do is you're going to delete this one. Okay, so now you can see that the counts are maintained. I think so. You can see that 3, 4, 5 times L and 5 times R. So what is the minimum number of operations required? You can see the minimum number of operations required is 2. Okay, in other words, you can easily understand that what is the difference between this value and this value, 7 and 4. You can see 7 and 4 is 3. So your answer would be, let's say, the ceiling value of 3. Okay, so if I'm not wrong, let us suppose that our answer is ceiling value of 3. Okay, so what is the ceiling value of 3? Like the absolute value of difference between the L count and R count, which is 3, and ceiling value of 3 is 2. So our answer is 2 right now. Okay, and okay, so let us suppose that both are even. Like first of all, we have worked upon parity of both being different, and now we are working upon parity of both being same. Okay, so if parity of both being same, let's say 6 and 8. Okay, so you have 6 times of L and 8 times of R, and the difference is 2. Okay, now you can see that the difference is being even, like absolute value of the difference between L count and R count is even. Then you can easily switch the, like you can easily switch any character to any other character, and finally you are going to have the all thing balanced. Okay, so in that case also you can see how your answer would be like difference as d by 2. Okay, and this is even, so this will be an integer. Okay, so in other words, you can also write down as your answer is like if the difference is, let's call it as diff is x, and if x is odd, then your answer would be like x by 2, integer value of x by 2 plus 1. And if x is even, your answer would be simply x by 2. Okay, so let us move on to the coding part. Okay, so you can see all the test cases has been passed. So what I've done is like take the input, count down LRUD. Okay, and if we are done with this, we are going to, like I've used this operation to ensure that L will contain the maximum value and U will contain the maximum value among U and D, and similarly L will contain the maximum value among L and R. Okay, so our answer would be like I'm going to find out the minimum number of operations. You can easily see I printed down the L plus U. So first of all, I will calculate for the x coordinate. So it should be like L minus R divided by 2, plus if it is odd, this will increment it by 1. Otherwise, if this is even, it will return the answer as 0. Similarly, for the y coordinate also, and finally print the total number of operations, which is the minimum number of operations required to complete this step. Okay, so this will give you all test cases passed. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to YouTube channel for latest updates. Thank you for watching this video.